Good afternoon, everyone. Thank you. It's 5 o'clock, so I'm glad to see all these faces out here. Today, I'm going to be sharing with you some of the performance improvements we've made in GridV and ListView in Windows 8.1. So I could tell you about all these great things, and Kieran actually stole a little bit of my thunder and demoed some of those features in the last talk, but I think it's more powerful if I show you guys the difference between 8.0 and 8.1, so let's do that now. So, on the right side of the screen, we are going to have the finished product. This is a GridV app working with optimized performance in 8.1. And on the left side of the screen, we're going to have a Windows 8 app. So the first thing that you'll notice is that when I launch these at the same time, the 8.1 app loads a lot faster. And so when I said a lot faster, I mean a lot faster. So there, now the 8.0 app is finally done loading. So that's the startup improvements that we've done. And now, not only have we improved startup, we've also improved the panning and performance. So as we start panning on these two apps, hopefully at about the same speed, you'll see that one falls behind and just shows black, while another one shows placeholders. But not only are these placeholders showing that there's more content coming in, they're getting incrementally updated as the UI thread has idle time. So we start showing data as soon as possible and building up the data that we're showing to the user. So today, we're going to take this 8.0 app, and we'll walk through all of the improvements that we've made in the framework. And my slides are very visual, so I like to walk over concepts visually, and then we'll make actual changes in the 8.0 app to get to the right side of the 8.1 app. So as you're watching this demo and this talk, just try and get the concepts. And then in the notes of my slides that you can download later, I have a lot of the technical details, and then we'll actually do this in practice on stage and show you actually what coding changes you need to make. So our little journey today, we'll start off by dealing mainly with panning, and we'll first start with how item virtualization can improve your startup and panning experience, move to showing placeholder elements, and then talk about how to code up an incremental update system for your app. And then we'll switch gears and talk about startup and talk about GridV Item Presenter and ListView Item Presenter, which are two new classes that we introduced to help increase startup by about 26% in ListView and GridView scenarios. So before we actually start talking about panning, let's review a pretty basic concept to XAML since WPF through Silverlight and now in Windows 8 XAML. So we have the idea of a data template and an item container template. A data template is, like it says, all about how you present your data. This is what you, the developer, create to make your GridView item show the data in your data items. So in this example, the data template's made up of an image and two text blocks. When we compare these two GridView items, we see that they have the exact same data template. We're showing the data with an image and two text blocks. However, they're bound to different data sources, which is why the first one shows the data for item 1, and the second one shows the data for item 2. The item container template is all about state. And this is something that if you use the default visuals that we provide in XAML for like selection or hover or focus, you don't have to think about this. But like all things in XAML, it's customizable and you can retemplate it. But the item container template deals with state. So we create some objects for you to display the data template. We'll create some more objects to show selection, a couple for pointer over, some for focus, and other ones for like panning, hover, drag, just the state of each GridView item. So when we're talking about panning, let's keep in mind the data template, how you present data and not the state of the item. So when we pan, or when a user pans, and you need to bring 3 new columns of content onto the screen, you'll have a very good experience if the framework can render all 3 columns of items by the next time we need to present a frame. If you can't, then you'll see the background color, which is usually black. And so we call this phenomenon scene black, and we try to minimize the amount of time that users see black in your application. So in this example, the framework only had time to render item 21, 22, and 23. It ran out of time, and it said, oh no, I need to give this frame up to the user, and then that's what got presented. So if the problem is creating items, then one solution may just be to create all the items up front. But that, after a little bit of thought, isn't necessarily the best idea because creating items takes a long time. In this example, we have at least 4 groups. Each group has 1,000 items. So that means that if we created each one of these items up front, your app would have to wait to create at least 4,000 items before the user saw anything. And so you'd see a long pause, even longer than we saw in the 8.0 app when we started it up. So in 8.0, we said, OK, that's not a good idea. Let's do group virtualization. So let's only show or render the items in the groups which are on screen. So that takes this example from, say, 4,000 items down to 2,000 items because we have 2 groups on the screen. There's 1,000 elements in each group, so 2,000 items get rendered by the framework. That's a lot better, but it's not good enough. We thought we could do better, and so we said, how about in 8.1, how about we just render elements that are near the viewport, regardless of what group they're in. So here, we're only rendering about 18 objects, the ones that are very close to the viewport, and the other 2,000 or so elements that are in the groups that are on screen, yet aren't close enough to be seen soon, we just put off until they get close to the viewport. Now, we implemented this by changing the default panels that ListView and GridView use to show items. So in 8.0, I believe ListView used virtualizing stack panel, and GridView used wrap grid. In 8.1, we've made the default panels item stack panel and items wrap grid. So if you're writing an 8.1 app, you get this item virtualization for free. But if you've overridden items panel on either a GridView or a ListView, I suggest that you try and just change it to be a items wrap grid or item stack panel, and then your app, recompiled for 8.1, will get item virtualization. So let's take a look at what it takes to move an app and the benefits you get from item virtualization over group virtualization. Oh, no, let's stay here first. All right, so this 8.0, oh, are we not showing it? Sweet. Great. I don't think I'm being slow. Okay. All right, sweet. Okay, so this app is basically based off the Visual Studio GridView project template, and I've stripped out a lot of the more extraneous things just to show us the grid view. So here is the actual grid view, and as you can see, the items panel is set to wrap grid. This is the default panel in Windows 8.0, and so now we could change it to the default panel in 8.1, or just completely get rid of this, since it will default to items wrap grid. And now, as we know, perf is very dependent on the machine that you run it on. So if I run it on this i5, well, it has enough horsepower to render everything very quickly. So I'm going to try and remote debug onto this surface. And as presenting over the years, I found that the one thing a demo needs is one extra way for a demo to go wrong. So hopefully this remote debugging will give us just that. Sweet. Okay, all right, so the right side is the app that we just created or updated to have the Windows 8.1 panels. And now we'll compare it to Windows 8, which uses group virtualization. So we'll first note that when I launch, the 8.1 app comes up a lot faster because we're rendering less items. So item virtualization first helps with startup, but then it also provides a better panning experience. As you see, the items on the right side come in and get realized a lot faster than the items on the left side, which is the Windows 8 application. Just to sort of look at the coolness of item versus group virtualization, watch how when these items come in, it's a whole group. So no group, and then that whole group comes in. Now that whole group comes in. Whereas if we do the item virtualization, notice that groups start coming in like piece by piece. See how they're starting to come in incrementally? So that's group versus item virtualization. So that helps you with not only startup, it also helps you with the panning experience. So let's take a look at what is actually happening on the UI thread when a user pans. Kieran described this in words, so I'll take a shot at describing this in pictures. So this is the moment right after a user's panned and the UI thread realizes that it needs to render 3 columns of items. Down below, the UI set thread says, hey, I have this budget. I need to do all of my work in this amount of time, and once that time's up, I'm going to give this frame and present it to the user. So it's going to do some work, and since we're bringing in 3 columns, that's a fair amount of work. We have to do layout. We need to move these items around, whatever else the UI thread does. Then after that, it starts rendering items one by one. So first it renders item 21, then renders item 22, and finally item 23. And after item 23 is done, we're out of time. The UI thread says, OK, here's the frame, and that gets presented to the user. So in 8.1, we thought, OK, we have all this space that's blank. However, we know that there's more items there. Let's show the user that there are more items there. And so in a fraction of a second, the UI thread will then just show placeholders, some blank placeholders, to the user just to let them know that there's more data coming in later. And this is controlled by a property that we added to GridV and ListView called shows scrolling placeholders. It defaults to true. So all apps running on 8.1 get it for free. So let's take a look at the improvements of placeholders over item virtualization. So we're back in our app. I had turned placeholders off to emulate Windows 8.0 behavior. We can just delete this. Oh, sorry, thank you. All right, now we're back in our app. And I had disabled placeholders to emulate Windows 8.0 behavior. Let's get rid of that because it defaults to true. So you'll get these placeholders by default. And we'll come back to our surface and remote debug. All right, so the right side is going to be placeholders. The left side is going to be item virtualization. They both start up at the same time because we didn't improve startup in this scenario. But now watch what happens when we need to bring extra items onto view. Now the grid view knows to show these placeholders while we're rendering items and not able to present it in that frame. So placeholders are nice, but we thought, why don't we go a little further? What if we didn't spend all of the time rendering a few items, but we spent a little bit of time updating all of the items? So in this case, maybe it gives the user a better experience if we showed the title and the subtitle for as many elements as possible instead of waiting to load 3 expensive images. It would have been great if we could have done that on your behalf. However, we don't know what your data template is. We don't know how you want to display data to the users. We don't know what data is important to your scenario. So we added an API that lets you do just that and gives you control over what parts of your data template get updated in what order. So let's look at how this might happen visually first before we go into a coding sample. So after 3 new columns need to be brought into view, and the UI thread has done its work, we chunk up the remaining time on the UI thread into something we call phases. And each phase is an opportunity for you, the developer, to update some part of all items that need to be brought into view. So here, the UI thread has done its work. Then in phase 0, we show placeholders for all elements. And we, being you, the developer, code this. In phase 1, you show titles for all new elements. And then in phase 2, you show subtitles for all new elements. But notice here that we didn't have enough time to show all of the subtitles. So the subtitles for 30, 31, and 32 were not rendered. Now what happens in that situation is the UI thread's smart enough to say, okay, we didn't get through all the work. I'll batch up that extra work and get back and do it when the UI thread is idle. So we're going to present a frame, keep the panning buttery smooth, and then update it when there's a little more time. So then in the next frame, the user kept on panning, and we only need to bring in 1 column of elements. Notice that since there's 1 column as opposed to 3, the UI thread has had to do a lot less work moving things around and going through a layout pass. We then do phase 0 for all the new elements which need to be brought onto screen, so we show placeholders for them. Then in phase 1, we'll show the titles for all the new elements. Now we're coming to phase 2, and the UI thread says, aha, I have some free time. Let me go and update the work that I sort of postponed from the last one. So now we showed the subtitles for item 30, 31, and 32. And now we do the phase 2 for all new items that are being displayed. And so that's showing the subtitles for items 33 through 36. Finally, we get to phase 3, which is showing the image background. And now our items are fully realized. We're done, and there's a little bit of extra time, and the UI thread gives that frame to the user. So all this magic happens in this new event called container content changing. And this is an event that will get called on every item when it's being brought into view. And the real magic in this event happens in the args. So the first thing we give you is a phase. And that tells you what phase you're in. You could be in phase 0, 1, 2. You decide how many phases you have. So as long as you keep telling us that you want to get called back to do another phase, we'll call you back. The only special phase is phase 0. Phase 0 is guaranteed to be called for all items synchronously on the UI thread when those items need to be realized. So we suggest that you do as little work as possible in all phases, because we'll come back and do that work later in idle time. However, we strongly suggest that you do very little work in phase 0, because if you do too much work, you'll exceed that budget of the UI thread, and then you'll start to see glitches. We also give you a method for registering a delegate. This is the delegate that gets called on the next phase. We also give you a way of telling us that you're going to be handling rendering your content. So when you set handled equals to true, the framework will not set the content on your element, on your grid view item. And we found that setting the content takes up to about 30% of the time of rendering an element. So when you're doing incremental updating, you want to make sure that you set handled to true so you get that 30% back to do whatever you want to do. The item container is the root of your data template. So this is good for finding elements in your data template that you want to update. So maybe you're in phase 2 and you want to update the subtitle. You go to your data template and say, find my subtitle element, update it, and then show it. The item is the data item that this grid view item is displaying. So you'll be pulling data from this item and shoving it into your data template. We also tell you whether the item's in the recycle queue or not, and an item index. So consider implementing incremental updating for any scenario where rendering items is expensive, because we think this will allow you to give your users a much better end user experience. So let's take a look at what that involves. So the first thing I'm going to do is I'm going to disable scrolling placeholders, because I'm going to take care of that myself. And that's just one thing that you can save the framework from doing, and just a tad bit more time for you as a developer to use. Then I told you that the magic of this happens in the content container changing event. So I'll register a handler for that. Oh. Sweet, it looks like I already had one and had not cleared this out. So let's use that. Apparently I had not cleaned this up for my last dry run. So here's our incremental update handler. The first thing that we'll do is add in the skeleton to this. So as you see, the first thing that I do is set handle to true. That gives me back my 30% from setting the content. Then I check that we're in phase 0. So this is the first handler that should get called. We should definitely be in phase 0. Just do some error checking. I don't know how you'd not end up in phase 0. That'd be kind of weird. Once we've decided that we're in phase 0, we're going to write some code to show a panning placeholder. And then we know that we're not done updating the element once we've shown the placeholder. We want to show the title. We want to show the subtitle. We want to show the image. So let's write a function to show the title. So now we should be in phase 1. Check to make sure that we're in phase 1. Write some code to show the title. And we're still not done, so we want to show the subtitle afterwards. And so this will get called back for phase 2. Confirm that we're in phase 2. Write some code to show the subtitle. Then register another callback to show the image. Confirm that we're in phase 3, show the image, and now finally we're done updating this element, so we don't need to be called back for any more phases. And to not be called back for a phase, we simply don't register a callback. So let's go back and implement showing a title, showing a subtitle, and showing an image. The first thing that we need to do is go back to our data template and make sure that we have an element in our data template that's sufficient to be a placeholder. So right now, we have a border which contains an image, so that's our background. And then we have a stack panel which contains two text blocks, one which is the title and one which is the subtitle. So let's add in a opaque rect, which will be used as the placeholder. So I've named it placeholder rect. It has a semi-green background because most of our other elements seem to be green, and it has opacity of 0. We can change it to 1. Either way, it doesn't matter because we'll change that when we implement our update handler. So let's go back. We want to show the placeholder now, so let's write that code. So what are we doing here? First, we get the data template root. From that, we find the placeholder rect that we just added. We find the text block that contains the title and the subtitle, and we get the background image border. The first thing we do is make the placeholder rect opaque. So now every item, or now this item, has an opaque placeholder. The next thing we're going to do is make the title, subtitle, and the border that contains the image transparent because we haven't had time yet to update the content in those elements. And then, as we saw before, we're going to register to get called back later to show the title. So now we want to show the title. This should look very similar. We get the selector item, and these are all args from the event. We get the data template root. And notice here, we're using the item container and item. So this is the data element that this GridV item represents. So once we find the data template root, we get the title text block, and then here, shove the title from the data item into the text block. But first, we leave the placeholder alone because we still want the placeholder. We're not done updating this item. Then we update the title, make sure it's opaque so that it's visible, and then leave the subtitle and image as they are because we haven't had time to update them yet. And again, we call back later to show the subtitle in phase 2. You guys can probably guess what this code looks like. Very similar to the last one. Get the data item, get the item container, find the subtitle, jam the data from the data item into the subtitle text, change its opacity to 1 so that it's now visible, leave the placeholder rect and the title alone because we want to still see those things, and leave the image alone and transparent because we don't want to see that thing. Update. Register our update to get called back for phase 3 to show the image. Again, very similar code. Get the data item, get the template root. Now we're going to get the placeholder rect, the image border, and the image. So the title and subtitle are all cool because we've updated them already with up-to-date data. The source of the image needs to be updated with the source of the image from the data item that backs this GridV item. We need to make the image opaque, so set the opacity to 1. And now we can get rid of the placeholder rect because we now have our image as the background and we no longer need to see the placeholder. And finally, we're done. So let's compare incremental updating to, what was the last thing we did? Placeholders. There we go. So on the right, we're going to have incremental updating. And on the left, we are going to have placeholders. So even as we launch, you'll probably see the incremental updating going through its phases very quickly. And now as we pan, you always see content. And you can see content coming in even as we load it up, as opposed to just a blank placeholder. And so now you as the app developer get to choose what you think is most important for your user to see first and do that on your own. So let's switch gears here and talk about startup. And before we dive into startup, let's revisit the idea of data template versus item container template, because when we're dealing with startup, we're going to be talking more about the item container template instead of the data template. So if we remember from the beginning of the presentation, the data template is how you show your data. You have image, 2 text blocks, same data template between these 2 items. The item container template is all about state, so you have some items to show the data template, some things to show selection visuals, hover visuals, focus visuals. Now we're dealing with these objects that it takes to show state. So the Windows 8.0 item container template was pretty expensive, and most app developers didn't even know that this was going on behind the scenes. So we created a set of elements to show the data template. Then we had another set of elements to show selection, yet more to do drag, and even more for pointer over, focus, placeholders, things like that. The problem is that creating each one of these items takes time, and it also takes memory. So for each GridV item, we created that large visual tree at startup. Doesn't seem like that big a problem, but then when you have a lot of items on screen, we're creating that many more items. So in this example, I think we have about 50 items on screen. That means when you first go to this page, you're creating 1,050 objects. Even worse is that we might not even use all 1,050 objects or any of them. For example, if no one ever selects anything, why do we need to create those elements for selection? Like, they just never get created. And even if you disabled selection, we'd create those. So you're paying a price for something that you're not even sure that you're going to use. So in Windows 8.1, we took that tree and reduced it down to one element called a GridV item presenter, or in the case of list view, a list view item presenter. And the job of a list view or GridV item presenter is to draw the same visuals in 8.1 that were created by all these UI elements in 8.0. And the GridV item presenter does that with very fast drawing primitives that are internal to the framework. And it only draws those things when they're needed. So you save the memory of creating all these objects, you save the time spent creating all these objects, and you only pay the price for drawing them when they're needed. So all apps that use the default item container template will get this for free in 8.1. And if you take an 8.0 app that uses the default item container template and just recompile it for 8.1, you'll get that for free as well. But we realized that not everyone likes the default look and feel of selection or other states. So we thought, okay, we need to provide you guys a way to change some of the look and feel of these items, but maintain the startup performance that we've given you. So maybe you want to go from this example, which is the default checked look, to an orange background and get rid of the check mark. We've added a set of properties on both GridV item and list view item presenter that lets you easily maintain the new template in 8.1, which uses these presenters, but just change a few properties on them to change how the framework internally draws all of your selection visuals. So if you want customized states, try to use the properties on GridV item and list view item presenter to do this, and then you'll automatically get the startup wins that we've given you in 8.1. So let's look at a quick example of how to do that. So any of you that are familiar with retemplating controls know this pain of going to generic XAML and finding the control template, all of this code, finding like the 3 or 4 properties that you want to change, modifying them, and then sticking this in your code. We've made that easier in 8.1, not the general retemplating process just for GridV item and list view item presenter. So let's just get rid of that old template and add in the template for a GridV item presenter. So now you can see that our control template simply consists of one element, and we've set 3 properties on this element to customize the theme of this app to my desire for right now. Turn that on. All right, so on the right side, we're going to have a GridV item presenter, and on the left side, we're going to have incremental rendering. This is all about startup, so we're not going to do any panning. But you should see on the right side an element. Remember that we changed the color of selection, so there's an item selected in both of these when they come up. The right side is going to be orange, so that's the 8.1, and then the left side is the standard purplish. So you should see an orange element come up faster than a purple element. Sweet. And so on 8.1, if you use these default templates, you'll get this startup improvement for free. So GridV item and list view item presenters are all about visual appearance. You can change some colors. We added a few properties to let you show and hide check mark. There might be a couple other things like that. But in general, it's not about the physical structure of the item container template. Basically, if you're using GridV or list view item presenter, it's we want the default Windows 8, Windows 8.1 visuals. We'll let you customize the colors some. You get your startup. But we realized that some people go above and beyond and want to show different ways of doing selection or state. So for example, this is the default selection. Maybe you want to change the color of an item in your data template to show selection. Or maybe instead of showing, believe this is the pointer over state, which is a semi-opaque gray rectangle behind your data template, you want to show that rectangle in front of your template. So now you've actually changed the structure of the visual tree. You've moved it from the back to the front. That's not something that GridV item presenter and list view item presenter are designed for. However, we have exposed a function called goToElementStateCore, which you as a developer can override and then add items to your visual tree as necessary based on the state that you're going to or coming from. So in this example, you might start off with a very sparse tree, which just is enough to show your data presenter. Then when you go to pointer over, you may add one rect on top of your data template to visualize that we're in pointer over state. Then if we went from pointer over state to selected state, you don't necessarily have to add any items because in this case, we're just changing the color of an existing item in our data template. So in that function, you probably went through, searched your data template, said, okay, where's that little rect there, and change the color of it. But you'll also want to remember that since you're no longer in pointer over, you'll want to hide the rect that's semi-opaque and above your data template. And we let you do this through the goToElementStateCore function, and that lets you build up your item container template as you deem based on the states that you go to and come from. In my notes, I have a more complex slide that sort of shows logic about how you decide what you hide and what you show, but I'll leave that to you guys to look over at your own time. So basically, we let you go from this very large and complex visual tree that gets created at startup for every item to a much simpler tree that only gets created on demand when you need those elements. So in review, item virtualization gives you faster startup and faster item presentation. We don't really render the items faster. It looks like it. It's just that we're rendering fewer of them, and we get them to the screen faster. So if you have a Windows 8 or 8.1 app that use default items panels. For Windows 8, you just need to recompile your app for 8.1, and you'll get that for free. And all 8.1 apps will get that for free if you don't change the items panel. If you do change the items panel, consider moving to the new panels. So for list view, that's virtualizing stack panel, and for grid view, that is, for list view, that's items stack panel, and for grid view, that's items wrap grid. Placeholders improve perceived performance, and all apps get it for free when you run on 8.1. Incremental updating updates all items instead of fully rendering a few items. And you can't get it on for 8. You have to use the new container content changing event that's available in 8.1. So that will take actual code changes in apps that were built for 8.0 and you move to 8.1. Presenters improve startup, we've seen in our labs, by up to 26%. Depending on how complex your data template is, that trade-off starts to change, right? Like if you have a very complex data template, more time is spent rendering the data template than the item container template, so you'll see less of an improvement there. Whereas if you have a very simple data template, more time spent rendering the item container template, so you'll see larger improvements there. Regardless, if you have default item container styles for Windows 8, you just need to recompile for 8.1 and you'll get this for free, and all 8.1 apps get this for free. If you have custom item container styles, change to use presenters. If you're just customizing colors, that's pretty easy, and you should be able to do that by just changing a few properties on GridV item presenter and list view item presenter. And for 8.1, definitely try and go through the presenters first. And then if that doesn't work, consider moving to go to element state core. You can get back towards that 26% startup gain. It's not on Windows 8, and you have to use that function that we added in Windows 8.1. So a lot of my notes are in the slide. The XAML Performance Fundamentals is the talk that was here before us, given by Kieran, and he talks about a lot of the things more in depth through words. And then there's some other great performance talks that are given by different people. They've mostly all happened or were during this time, so you might want to go back, look, and find them online as you feel fit. My last ask of you is that you guys help me become a better presenter and let me know what I did well, let me know what I could have done better, and then in the future, hopefully my presentations will be better for you guys. So I'd like to open it up to questions now. If you guys go to the mics, that's better because then everyone can hear it. Otherwise, I'll try and repeat your question. We have 16 minutes. Sweet. I feel like I forgot some slides, but so yeah, feel free to go to the mics or just come up to me and talk whenever you feel like it. So the question was, how do XAML template selectors affect incremental loading? Let me think about that. I'm going to assume, so as you're panning, you'll be recycling in containers, the ones that are leaving the viewport and coming back over here. I'm going to assume we're going to recreate that data template for you, because that would be a time where we're not sure. I don't think that would necessarily, actually, they're probably orthogonal. So the framework's going to decide whether or not we can reuse a data template. And so when it gets recycled, if it sees the same data template for that data item, like say it's the image in 2 text blocks, I assume we will then recycle that data template, and you'll be able to find those items in there. If it was a different one, then I would assume we would recreate a new data template for the information that's going to be there. I wonder if Kieran's still here. He might be able to answer that. But that's my assumption based on my knowledge of the framework. So the question was, can this be applied to any other applications like ASP.NET or things like WPF? No, this is Windows 8.1 XAML only. It doesn't even apply to Windows 8.0 XAML, unfortunately. Start there, the mic.
So what about the variable size wrap grid? Does that have any of the same performance improvements?
That's a very good question. No, so item virtualization is single size items only.
All right.
Let's go over here.
You set the opacity to 0 in your placeholders.
Yes.
Is there a performance cost if
Yes.
they have opacity 1 and with no content?
Okay. So there's two things I want to hit on. Thank you for reminding me of that. I very specifically set opacity as opposed to visibility. Visibility is going to change layout and make you go through layout and make the UI thread spend more time on that item. Opacity is just going to, like, the render thread will take care of that and not show it. So definitely set opacity and not visibility. The other reason why I'm setting opacity or making these things invisible or not gets back to his point that we're recycling data templates, right? So say we start with elements 1 through 10, right? Move off, and we're now on item 11. We're going to take the data template, the objects that we use for the data template, and recycle them for element 11. However, it's going to still have the old data there, right? So if we don't hide it somehow, it's going to show 11, or the information for 1. And so that's why we hide everything first, then make sure that we pumped in new data, and only reveal them as we pump in the fresh data. So thank you for that.
Yeah, I have a couple questions.
Yep.
So I noticed in this sample, you're setting the text in the code.
Yes.
Does it work to have the text data bound rather than having to set it, reset the text in each phase?
So that's exactly what the setting content does, basically. And so I'm specifically not using data binding, so I can choose which parts of the data I update when. Otherwise, everything's going to get updated, and we'll be back into the situation of 8.0 where it's taking a long time for each element.
Gotcha. My next question kind of relates to the opacity thing.
Okay.
Can you kick off an opacity animation from one of those phases so it's not so jarring when you go from the placeholder to the actual content?
I don't see why you couldn't. However, I don't know if you'll ever really be able to see that. Depends on, like, what you're doing.
Sure, I mean,
Hopefully
you wouldn't see it until you stopped panning.
Yeah. Oh, so you're saying start the animation once you stop panning?
Or I guess once the last phase is completed, I assume at that point you're sitting at enough time to render anyway.
Yes, you could.
Okay.
That would, or I assume you could. I've never tried it. But that would also, I would question how useful that would be. Just because you don't necessarily know when you stop panning. And just because you're moving doesn't mean you don't want to show something, right? Because, like, I could be panning very slowly, and my phases will still be getting called. And I'll be going through my phases, and I want to show that data as quickly as possible. And in theory, those phases should go so fast that you don't need an animation there anyway.
Sure. Okay.
Another point to that I went over quickly in my presentation is that all phases, phase 0 is the only phase that's guaranteed to be called. Like, I showed phase 2 getting delayed until time was idle. We could choose not to do that work, but that wouldn't be a bad thing. So we would only choose not to do that work if, say, we were panning really fast and the items that did not get done with phase 2 are now out of the screen and no longer need to be rendered and being recycled. So now that's work that we've saved you from doing. So, yes.
Sure. Okay, and then my last question probably relates to the variable size wrap grid.
Yes.
So I know in WPF we could implement iScroll info and do our own container virtualization. Can we do that with Windows 8 XAML?
I don't believe so.
Okay.
But if you want to come give me a card later, I can follow up on that for you if you'd like.
Okay, thanks.
Back to the left. It's a lonely mic over there. Maybe one of you wants to go over there.
Now I lost my question.
Sweet.
Yeah, no. For instance, we have images coming in over the network. So if I do a slow pan, is it actually registered you were done with phase 2, but the data was not there yet? So will the image still, like that item still go into phase 2 again? So my image came in over the network in the meantime, and then it will render the image?
If you set the source and it took time to download, I believe that it would finish phase 2 and then show it once it was done downloading, depending on how you implement it. If you block to wait for that image to download, it'll probably block phase 2. If you do that, if you kick off like an async download, then it should pop in when it's done.
Okay, even though it was already marked as I've been done with basically most of my stuff.
Yes, I believe so.
Hi, in the incremental updating that you showed, it seemed very imperative. It's a chain of callbacks, callback, callback, callback,
Yes.
callback. Are you planning to do anything in XAML where I could say, hey, here's my template, this is the placeholder, this is the priority 1 element, this is the priority 2 element, render what you can, don't make me write tons of code to do this stuff? Because a lot of it looked boilerplate to me.
I can see why you say that, and the Blend guys are, I've heard, busy at work making a behavior just for that. I was oof right before I came here, so I didn't get a chance to work their demo into it, but those behaviors are not available with the build release, but they tell me that those are coming.
Okay, so this would be something that Blend would do rather than you would do
Yes.
right in the
Yes,
in the
I believe
core
they
engine?
tooled that, and if I remember what I saw, it was like you could set what phase you wanted a piece of your data template to be realized in.
Okay,
And so if you're familiar with behaviors at all, it's implemented as a behavior.
okay, all right, cool, thank you.
Yep. Yeah, there's no one over there, so please.
Do you get an event when your elements are being destroyed, when they're going out of view? Because I might have to like unbind some event handlers and things like that so the element can get garbage collected.
So that's what, so yes, you'll get that CCC, the content container changing or container content changing event. And then you can look at there's a Boolean property in recycle queue. If it's in recycle queue, it means it has been moved out of view, but is not being rehydrated with data.
And do I know what phase got executed for each one of those guys? Because I might be doing stuff in different phases. I probably wouldn't do that, but I might.
I don't know if you ever really want to, I mean, I don't think so. I think you'll get, well, I mean, you could, right? So you could check to see if it's in the recycle queue, and then in phase 0, unhook one thing, register a callback to unhook something else in the next phase. You could do that. It's really up to you as a developer.
Okay, thanks.
Sweet. Do we have any other questions?